So this is a very quick overview of our paper titled Exploring the Steiner-Soddy Porism with Professor Ronaldo Garcia from Universidade Federal de Goiás, Liniana Georgi from Universidade Federal de Pernambuco, and myself, data science consultant. So very quickly, this paper is going to explore certain geometric properties of a family, this orange polygon family, derived from a well-known geometric object known as the Steiner chain. So the Steiner chain is a set of n circles, in this case n equals 5. They're all mutually tangent, they're sort of pairwise tangent to each other, and all of them are tangent to an outer circle known as the Soddy circle and an inner circle known as the inner Soddy circle. And this chain is a porism in the sense that it has a one-dimensional family associated with it. It can glide right within this circle and about this circle here. And it is a porism because it is the image under inversion of a regular setup. And we go into more details in the video. What we're going to talk about in the video is about properties that we discovered of the family of orange polygons whose vertices are centers of circles in a Steiner chain. So as the Steiner chain rotates and glides, this porism, right? What happens to this orange family of polygons, and also this magenta family of polygons, which is actually defined, whose vertices are defined or located at the points of pairwise contact between circles in the Steiner chain. So it turns out both families are Poncelet porisms. The outer one is inscribed in this conic, this ellipse in this case. It can be also a parabola or a hyperbola. But the interesting thing about the outer conic is that its foci, F1 and F2, are the precise centers of the inner Soddy circle, to which all the circles are tangent, and the center of the outer Soddy circle, to which all circles are also tangent. Okay? And this family, as its caustic, as its Ponceletian second conic, internal conic, is a circle. So it's this dashed circle here. So here you have this Ponceletian circle. By the same token, the magenta family is also Ponceletian. And we show that the outer and the inner family, so the orange and the magenta family, conserve special quantities related to sums of tangents and cotangents of their angles. The other thing we're going to do in the presentation, just to finish, is very quickly show you guys some properties of loci of triangle centers when we're talking about Steiner-Soddy family, which is what we call the family of orange polygons, when n equals 3. Okay, so I'll see you in the more extended presentation. Our emails are provided here, and just let us know if you have any questions, comments, suggestions. Thank you very much.